Now, let us go with question number 4, classroom workbook. In this session, we start with question number 4. I think in the last session we have done with question number 3. Now let's go with question number 4, classroom workbook. So what is asking actually here? V value. Find V naught. The first question, V naught. 2 is power of each source. Power of each source. Power supplied or absorbed by each source. Okay. This is the question number 4. So let's see. All of you once again note down in your notebook the same problem given in the classroom workbook. Okay. Now onwards, no investigations. Only we will apply our experience here and get the answer in less amount of time. This is 9 volts, 6 volt, 9 ampere. Okay, this is current source, right? 9 ampere, 6 volt, and 3 ampere, 1 ohm, 1 ohm, 1 ohm, and 1 ohm. Understand? Okay. Now what is asking actually here? Minus plus V naught. And also is asking what are the powers of each and every source. Okay. Please quickly note down that network and we will solve it now. Now let's see how simply we are going to solve the network. Remember, whenever you come across a network, you have only 2 options, I am telling you. If it is a multi-source network particularly. Of course, a single source network can also be solved. But multi-source networks generally you can solve using mesh analysis or node analysis. Yes or no? Either mesh analysis or node analysis. Now, in this particular problem, if I ask you the question, what is the best method? 1, 2, 3, 3 minus 2, only one equation you are getting using mesh analysis. Yes or no? Okay. Only one equation you are getting. Node analysis, if you choose, how many equations you get? How many equations you get if you go for node analysis? How many nodes are there? First you count 1, 2, 3. Okay. And there is no ideal source without series resistor. There is an ideal source with series resistor. Yes or no? Okay. Then 3 nodes, 3 minus 1, 2 equations you require. What is the best method actually here? No doubt mesh analysis. Because mesh analysis is giving less number of equations. But I solved this problem using node analysis. So what is the reason why you are choosing the node analysis? You can ask me. I can tell you that there is a current source with a parallel resistor. I can go for the transformation. Thereby I can reduce the number of equations. But it does not mean that the minimum number of equations is 1. It is minimum number of equations is 2 using node analysis. But using mesh analysis, only 1. Finally, what are the minimum number of equations to analyze this network? Only 1 that you can achieve through mesh analysis. Yes or no, all of you? But since we already experienced, the transformation can be exploited to reduce the number of equations here. Yes or no, all of you? Okay. So please put a note and write down here. Now you might be understanding that where the transformation is very much useful, particularly here, right? So put a note and write down. Source transformation can be utilized. Source transformation can be utilized to reduce the number of equations. In node analysis. Okay. What is the best method? Mesh analysis. Okay. To solve this network, you are preferring what? Node analysis. You cannot choose node analysis at the cost of more number of equations. That is why I am telling you here, using the node analysis, I am again still, you're applying with only one equation. utilizing this source transformation. Okay, look at this source transformation. So what is the network you are getting here? I generally advise the students not to draw the network again. Just by observation in your mind, you have to calculate everything. Okay, you don't have that much time in the exam. But if you have any confusion, if you feel that you are confusing, then better you draw it. Nothing to worry about that. Look at this. What is the network I am getting here? Downward direction, 3 into 1, 3 volts, but downward direction, therefore the polarities are minus plus. This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 6 volt, and this is 1 ohm, this is 9 ampere. Yes or no? Okay. Now, let us take this is 0, this is V, and V off. Now, let me apply 1 by 1, 1 by 2. You can't take 1 by 1 because this is in series with the current source. I told you in the last session. Okay, I told you in one of the last sessions, previous sessions, when there is an element in series with the current source that can be neglected as far as node voltage are concerned. Okay, now therefore is equal to 6 by 1, touching negative minus 3 by 2, entering current plus 9. Okay, therefore now you can find, now it is 1.5, that is 3 by 2. Okay, now it is 12 minus 3 plus 18 by 2. 2 gets cancelled. Now you understand 12 and 18. It is 30. 30 minus 3. Yes or no? 30 minus 3. 27. Now 3 9 ja. That is V is equal to 9 volt. Okay. This is actually what? 27. Okay. 27 by 3. Nothing but 9 volts. Now let's come to the points. V0 and power of each element. Remember, whenever the network is given, whenever he is asking a question here, you find this, you find that, first you keep it aside and your focus must be on how to solve the network, whether mesh analysis or node analysis. Understand all of you, okay? Now solve the network using mesh analysis to find mesh currents. Solve the network or else solve the network using node analysis to find node voltage. Once you know either mesh currents or node voltages, I'm telling you, you can find anything that you want. That is why first you keep this question aside. Your focus must be always on what? How to solve the network. Understand? Okay? Well. Now, once you know the V, let's go back to the network. This is 0, right? This is what? V. Now I want to find V0. What is V0 actually here? It is a potential difference across what resistor? Yes or no? Potential difference across resistor. This point is operating at V and this point is operating, because it is 0, this is 6 volt. This is 6 volt. This is V. Therefore, since you want plus minus polarities, better you assume 6 is greater than V, so that V0 is equal to, okay, first question, right? V0 is equal to 6 minus V, that is 6 minus 9 minus 3 volts. Now the second question, power. Power of 6 volts first. Power of 6 volts is what? Actually 6 volts into current through 6 volt. Current through 6 volt. Current through 6 volts, current through any path. You understand? Current through any path. Current through any path, what is the procedure again? If that path is having a resistor, apply Ohm's law. Otherwise, go for KCL. I think you have a resistor here. Apply Ohm's law. What is the current flowing through resistor? If you find current through resistor, it is nothing but current to voltage source. That is why V minus 6 by 1. Yes or no? Current, what is this actually here? V minus 6 by 1. That is downward direction because you are taking V greater. Okay. Therefore, 6 into V minus 6 by 1. 6 into V is 9. 9 minus 6. 3. Okay. Therefore, 18 watt. But what is the current direction in this source? It is downward or upward? Downward. Yes or no? Okay. Downward means it is absorbing the power, right? Because entering into positive, okay, it is absorbed power. Now, power of, what is that? 3 ampere. Power of 3 amp. First, let us see power of 9 ampere. Okay. Power of 9 ampere. See, to find the power of 9 ampere, you must know the voltage across it. Yes or no? You must know the voltage across it. Can I say the voltage across this one is some Vx? Yes or no? Nothing wrong in that assumption. Sir, how you got the polarities plus minus here? I'm just taking randomly. Okay, let me see, how I'm going to get whether it is a positive value or a negative value. Doesn't matter it is. Okay. Now, if this is 0, okay, one procedure, I'll explain you two procedures here. You can apply KVL or touching concept to get this value plus to minus like this. Yes or no? Assume some voltage Vx. I think we did the same procedure in mesh analysis. One problem I have taken where I determined the voltage across the current source. Voltage across the current source is normally determined using Kirchhoff's voltage law or touching concept. We put a different name for it. Okay. So start at plus and reach minus. Find the voltage here, touch the polarity, find the voltage here, touch the polarity, find the voltage. Already you have 6 volts. You can apply touching concept. But the advantage in the node analysis, there is no need to apply that KVL or touching concept. You can simply jump from this point to this point. Then obviously this voltage is nothing but what? Voltage across current source. Because this is taken 0, the voltage at this node will be definitely same as the voltage across 9 ampere. So what is the voltage across this one? The voltage across this one is 9 into 1, 9 volt. Because these two are in series. All the time the current flowing here is 9 ampere. Now jump from this point to this point. V plus 9. Why I am taking plus 9? Because you are jumping from negative polarity to plus positive polarity. Increase in voltage. Take the voltage. V plus 9. How much it is? 9 plus 9, 18 volts. Therefore, the voltage across the current source is 18 volts. Therefore, the power of 9 ampere is equal to, okay, 9 into this 18 you are going to get, and whether this supplied power or absorbed power. What is this, supplied or absorbed? Because the polarities of the voltage 18 volts is like this, and this is 9 ampere. This current is leaving from positive, therefore it is supplied power. Okay? 9 8 ja. So 2, 9 1 ja plus 7, 162 watt. It is supplied power. That's it. Okay. Now power of 3 ampere nana. How do you find power of 3 ampere? If you want to find power of 3 ampere, you must know this voltage. Yes or no? Jump from this point to this point. Say this is Vy, assumption. That means this is going to be what? Vy. Now jump from this point to this point. Jump from this point to this point. To jump from this point to this point, you must know what is the current flowing here. You must know what is the voltage here, right? What is the voltage here? For that you need current here. So let me find the current here. What is the current actually here? V plus 3 by 2. 9 plus 3 by 2. 12 by 2. Okay. Because 2, why I am taking 1 plus 1? V plus 3 by 2. Okay. 9 plus 3 by 2. 12 by 2. 6 ampere. Therefore, the voltage across this one is what? 6 volt. Therefore, jump from this point to this point. What is the voltage here? This is Vy, right? This is Vy. This is also Vy. Yes or no? Okay. So, the same thing you can apply here, plus minus 6 volt. Okay. And jump from this point to this point. What is that voltage you are getting? V minus 6. 9 minus 6, that is 3 volt. Okay. Now, the same voltage is appearing across the current source, that is 3 volts here. Okay. Therefore, now 3 into 3, 9 watt. Now what is that current source and voltage polarities? The current source is how much actually here? 3 ampere. The voltage polarities are plus minus Vy. Current is leaving from negative, nothing but entering into positive. Therefore it is absorbed power. This is the best example to understand how we calculate the power of voltage source, and current sources. Please note down. Okay, I think all of you understand that. Usually we prefer node analysis for our convenience. The calculation will become very simple and easy when you prefer node analysis. And the confusion is also very less. Actually, you don't get any confusion at all when you go for node analysis. That is why we prefer node analysis. But still, we don't compromise in reducing the number of equations. We look for all possible ways to reduce the number of equations. For example, here, strictly speaking, we get two equations, right? But we have utilized, I told you we are going to utilize all possible ways to reduce the number of equations. The source transformation is exploited or utilized to reduce the number of equations. That is why we got only one equation in the node analysis. Once you find this node voltage, you can find anything that you want in the network. Okay? And particularly the jumping technique will help you a lot. So I think you understand the voltage across the current source, how I determine. To find the power, we definitely require the voltage across it. To find the voltage here is nothing but what voltage at this node. I just jump from this point to this point. To jump this, I need the voltage. To find voltage, I need current. I found the current here. Look at this. This current is same as this current. Yes or no? This voltage is same as this voltage. Yes or no? That is why I got the current here. 6 ampere. 6 into 1, 6 volts. Jump from this point to this point. Higher to lower. Drop the voltage. V minus 6, 3 volts. The same 3 volts is appearing here. Okay? I think it's very clear, all of you. Note down every point clearly, because again you may get confused tomorrow when you see your notes. Clear? Now let's go with another problem. Let's go with another problem. Question number 5. Question number 5. Classroom workbook. Question number 5. Classroom workbook. Question number 5. This is a very interesting problem. We get a lot of information from this. Note down once again in your notebook. You must be good at simplification and should not do any mistakes in the calculation. I'm telling you, there are many students are losing their better scores because of silly mistakes in the exam. Now he's asking here, find find V1, V2 values and also find power of each source. Power of each source. Okay. So let's do this. Let's do this, all of you. Now immediately upon given the network, looking at the network, okay, you realize only you have two options, right? One is mesh, the other is node analysis. How many equations you require using mesh analysis? 1, 2, 3, 4. 4 minus 2, 2 equations. Mesh analysis will give you 2 equations. Node analysis, 1, 2, 3. Before you conclude 3 minus 1, n number of nodes, n minus 1 equations, check whether there are any ideal voltage sources without any series resistors. Yes, there is an ideal voltage source without any series resistor. Therefore, n number of nodes, n minus 1 equations will get violated. Okay. So, n number of nodes, n minus 1 equation doesn't work here. Okay. Now, if you select this node as 0, this is going to be 2 volts. This is an unknown value according to reference node shifting method. If you shift this reference node from here to here, then what are you going to get here? This is 2 volts. This is unknown. Therefore, 1 equation is enough. So, minimum number of equations required to solve this network is only 1. And that you can achieve through node analysis. Yes or no? Okay. But here, given this is 0, V1, V2 is asking, definitely you are supposed to find what? You are supposed to find using supernode analysis. Yes or no? We apply both the methods here because sometimes you cannot escape from the supernode analysis. I told you already. In the upcoming problem also we are going to see that. Okay. We should be expertise in both reference node shifting method as well as supernode analysis. Okay. So let's do that. So first one we start with supernode analysis and then we go for reference node shifting method. Okay. So let's do that. Now, what is the first step in supernode analysis? Method 1. Okay, method 1. We will do method 1, supernode analysis. What is the first step? Supernode analysis. Express the node voltage in terms of voltage source value. It's the first equation. And suppress the voltage source. Yes or no? Suppress the voltage source. That means short. Once you short it, this is also shorted. It can be neglected. Yes or no? Because that resistor is across the short circuit, that can be neglected. So this is also neglected and finally you are having a supernode here. This is 2 ampere. This is 2 ohm. This is 4 ohm. This is 7 ampere. Okay. Now what do you get here? What do you get? The equations. This is V1. This is V2, right? Previous branch voltage you are supposed to maintain. Minus 2 plus V1 by 2. Okay. Plus V2 by 4 plus 7 is equal to 0. Just solve these two equations here. Then you will get V1 and V2. Solving V1 and V2 values. Solving equation 1 and 2, let us say. You get V1 and V2 values. Understand all of you, okay? Well, once you know V1, V2 values, you can find the powers. Yes or no? Okay. Now, let us go with the method 2. Method 2. Reference node shifting method. Reference node shifting method. Okay. According to reference node shifting method, let me draw the network again here. Look at this. Okay. What is this? 7 ampere, right? This is 2 ampere. Suppose if you select this one 0, then what is it going to be? 2 volts. This is going to be what? V. So V minus 2 by 2, V minus 0 by 4, minus 7 plus 2. But inspection if you apply 1 by 2, yes or no? 1 by 4. This is leaving current is equal to minus 2. 2 by 2, I told you already that when node voltage is constant, okay, when node voltage is constant, okay, you must take 2 by 2 plus 2 by 2 plus 2 by 2. Okay. Don't take 2 by 10, okay, because there is no way related here to this node. Therefore, you can't take like that. V minus 2 by 2, therefore 2 by 2 you will get it. And what about this? Plus 7 amperes. So please simplify it. Now V of, okay, this is 2 plus 1, that is 3 by 4. 2 2 ja, okay, 2 1 ja, 2 plus 1 3, 4 is equal to, now what do you get here? Minus 4, I think you got 1, right? So 8 minus 2. What is this here? 8 minus 2 means 6. So 3 2 ja. So what is this actually here? V is equal to 2 into 4, that is, okay, 8 volts. You understand all of you, okay? What is the V value here? V is equal to, you get now, what is this 1 by 2 plus 1 by 4? Actually it's a 0.5 plus 0.25, 0.75, nothing but 3 by 4. Now already you got 2 by 2, that is 2 by 2, 1. This is plus 7, this is minus 2. So 7 minus 2 is 5, 5 plus 1 is 6, okay? So 3 2 ja, but 2 into 4, 8 volts. Yes or no? That means you got here, taking this node as 0, you already have this is 2 volts. What about this one? This one you got 8 volts now. Yes or no? V is equal to. But what do you want actually taking this node as 0? What is the voltage is asking? Understand all of you? Okay. Now, if you see that, now this must be made 0. Yes or no? Then what will happen? This will become 2 minus 8, that is minus 6 volt. And this will become, okay, this is V1, right? This is V1 now. According to that, okay, then V2 will be nothing but what? 0 minus 8, that is minus 8 volts. Understand all of you? So even if you simplify these two, you get V1 is equal to minus 6 volt and V2 is equal to minus 8 volts. I hope you understand the point here. This is how you can calculate. Okay. So please note down these two, and we will then discuss how to calculate the powers of each source. Okay. That you got actually here. Okay. You got V value, and from that you determine what is V1, what is V2 also, right? So which one is better? Dealing with two equations or one equation? Obviously with one equation, right? But once you deal with one equation, you must go back to the question that he is asking with this 0, okay, with this 0, what is V1, V2 is asking. That means you must reduce this voltage by 8. If you reduce one node voltage by 8, then every node voltage is reduced by the same value. So this is V1, 2 minus 8. This is V2, 0 minus 8. That's it. Now let us find the powers. What is the power of the two current sources? Already you know V1, V2, right? So what is power of 2 ampere? What is the power of 2 ampere? 2 ampere is V1 into 2. What is V1? Actually you got minus 6 volt. Minus 6 into 2. Minus 6 into 2. Okay? Minus 6 into 2. Minus 12 watt. Now V1 polarity is how it is going to be. Definitely V1 minus 0. That means plus minus V1 into 2. Supplied power or absorbed power? Supplied, because current is leaving from positive. But plus 12 watt, how it looks like? Absorbed power. Okay. Next. Power of 7 ampere. Power of 7 ampere. What is this voltage actually here? Polarity is plus minus, current doing what? Leaving from negative Therefore, V2 into 7, what is V2, Nana? You already got here minus 8. Minus 8 into 7, minus 56 watt. Yes or no? Okay. Supplied or absorbed? Because the current is leaving from negative. Because the current is leaving from negative. Here it is leaving from positive. Here it is leaving from negative. Leaving from negative. Nothing but entering into positive. Absorbed power. But plus 56 watt supplied power. Power of 2 volts we would like to find. To find the power of 2 volts, you need current through it. Understand? Okay. Again, current through any path. How do you find current through any path? What is the procedure? Current through any path can be determined either by using Ohm's law or by using KCL. If there is a resistor, apply Ohm's law. If there is no resistor, then apply KCL. Look at this. Is there any resistor in this path to find the current through 2 volt? No. Then go for KCL. For finding that current using KCL, let us assume some current. In whichever the direction you want, you can assume, nothing wrong in that. Randomly you can select some current Ix is flowing. Sir, I want to take in this direction. No problem, you can take. Suppose if I take in this direction, I got, let us say, 10 amperes. In opposite direction, if you take, what is the answer that you get? Minus 10 amperes. I think both are same, right? That is why do not worry about that and don't tell that based on the polarities I am selecting the current direction. That is not a correct explanation. Understand, all of you? We do not know what is the current magnitude, how much it is flowing, whether it is positive or not or negative, which direction it is flowing, we do not know. We start with an assumption. Okay, therefore Ix, some current is flowing here. Now let us apply KCL either at this node or at this node. Doesn't matter, anywhere is okay. Now if I apply KCL, this is actually procedure for what? Power of 2 ampere. This is power of 2 volts. Okay, power of 2 volts procedure. Okay, we are applying KCL at node A. Okay, KCL at node A. That Ix is actually entering and V2 by 4 is leaving, plus 7. And what about this 2? Because this current should also be taken. 2 volts by 10. How much it is? 2 by 10. This is 2 volts, 2 by 10. And the direction of the current in this element is based on the polarities. It is what? 2 by 10. 2 by 10 is 0.2 ampere. Understand? So 0.2 ampere is entering. 7 is leaving. V2 by 4 is leaving. Ix is entering. Therefore, here I can take 0.2 ampere. Now, if I take Ix, what is actually V2 here? Minus 8. Okay? 4 2 ja. So 7 minus 2. 7 minus 2, 5. So Ix is equal to 5 minus 0.2, nothing but what? 4.8 ampere. Now what is the power of the 2 volts now? 2 into Ix, right? So 2 into 4.8, 9.6 watt. What is the current doing actually? Entering into positive. See, my assumption is correct. I got positive value and that I realized only after finding this value, not in the beginning. Yes or no? That is why do not worry about the direction. You can take randomly. And this is now absorbed power. Okay, 12 watt absorbed here, 56 watt supplied and 9.6 absorbed. And don't apply Thelian's law only for these 3 elements. You need to apply Thelian's law for every element, all elements together. Okay, one of a student was asking in the classroom, sir, power is not getting balanced. How come you balance the power only for 3 elements? You must calculate the power of each and every element. Then you check whether power is getting balanced or not. Understand? Okay. So this is how you can find the powers. Please note down quickly. Okay. Then I will explain one more method in this. Hope you have done. All these calculations are over. Okay. Now, let us see. What are the methods we applied actually to solve this network? First method is supernode analysis. Okay. Second method is what? Reference node shifting method. Because that will give you less number of equations. Supernode analysis we applied here only for the experience sake. Because I told you that there are certain cases where you cannot escape from the supernode. Understand? Okay. I'm going to give you the next example, that one only. Okay. Now, this same problem can be solved without supernode and without reference node shifting method. If you closely observe, you can understand that. Understand all of you, okay? See, this particular portion, you see how these two elements are connected. Parallel. Current source with a parallel resistor can be transformed into a voltage source with a series resistor. Okay? And one more observation is that there is a resistor parallel to an ideal voltage source. Yes or no? Any element parallel to an ideal voltage source can be neglected or not? We already discussed this point. Yes or no? Okay? We already discussed this point. Any element parallel to an ideal voltage source can be neglected. Any element in series with an ideal current source can also be neglected. So therefore, this element can be neglected. This is neglected and this is transformed. What will happen? All these elements will become in series. I think you don't need to solve this network with two equations. You can solve with only one equation. V1 let us take. Okay. So please, okay, write down here. Method 3 here. Okay. Method 3. What is that? Neglecting 10 ohm resistor as it is connected parallel to, write down, parallel to an ideal voltage source. This is one point. Another point, applying source transformation to 7 amperes, 4 ohm. Now the result is what actually you are getting. Neglecting and applying source transformation, you are going to get the network like this. Actually, without drawing itself, you must write the equation. But still, I'm drawing for more clarity. For certain students may get confused. That's why I'm just okay, drawing it. Look at this downward direction means what? Minus plus, right? These are the terminals across which the transformation is taking place. And this resistor is neglected already. This is 4 ohm and 4 into 7, 28 volts. This is 2 ohm and this is 2 ampere, right? 0 and this is V1. Now this is V2 actually. Okay, this is V2 actually. We will come back to this later. Once we find V1, we know how to jump from this node to this node. This is 2 volts. Now let us go with V1 off. Let us apply inspection on 1 by 2 plus 1 by 4, okay, is equal to, tell me, is equal to, okay, plus 2, because this is entering current outside, plus 2, touching positive first, touching negative first. Therefore, you can see plus 2 minus 28 by 4. Okay, so what do you get here? Tell me. V1 of 3 by 4. Okay, what is this actually here? Minus 28 plus 2. Okay, what do you get here? Minus 26. Okay, minus 26. Yes or no? So, what do you get here? Let me take 8. What is this actually? Yeah, plus 2 and minus 28. So, what do you get here? Minus 26 by 4. 4 get cancelled. Then what is the value you are getting actually here? Minus 26 plus 8. 4 2 is 8 and this is minus 28, right? So what do you get here? Tell me. Minus 26 plus 8. What do you get here? 18? Yes. Minus 18? Yes, exactly. This is minus 18. Okay, then what do you get? V1 is equal to minus 18 by 3, 3 6 therefore minus 6 volt. Once you know this is minus 6 volt, you can jump from this point to this point, and you are dropping the voltage because you are moving from higher potential to lower potential. Then V1 minus 2, the minus 6 minus 2 will give you minus 8 volts. See this, how you are able to solve it. See, the same problem can be solved. The same problem can be solved, okay, with a different method. See, one must be good at solving the network, I'm telling you. Once you come across the network, you must be in a position to smash it. If you carefully observe the problems what I have taken and explain the way, and if you are really able to digest all these things, okay, in a systematic manner, I'm sure that you can solve any network that you come across without any confusion and with less number of equations and with less amount of time. Got it? Please note down. Method 3. Okay. Please note down that. Meanwhile, I'll note down another problem here. Note down each and every point clearly. Okay. This is a very good example to understand. So please practice again and again the same problem. First you practice and try to understand in detail. Okay. How we solve in each method. Every method is important, Nana. Supernode analysis is important. Reference node shifting method is important. Okay. Every method is important here. Now let's go with the 6th question. Remember, each session here it is scheduled to be only 50 minutes. Okay. So what will happen if anything is left over in this session? Do not worry. That will be continued in the next session. Okay. Because the schedule is only for 50 minutes. Sometimes the problem may be stopped in the middle. So don't worry about that. That will be continued in the next session. Okay. So classroom workbook problem number 6. This is a problem given. Okay. All of you please note down once again. Find V1, V2. Find the power of 10 volts, the power of 5 volts. Okay.